One, this is the permutations worksheet. Permutations worksheet. And we're going to be looking at number 9, 10, and 11 right here together, all three, because they all relate to the same kind of problem. We basically have 5 men and we have 5 women. So 10 people altogether. And number 9 says, how many ways can these people be arranged in a photograph in one row? So it sounds like this is one of those problems where we have no restrictions. We just have first person, second person, third person, fourth person, and dot, 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 5, 6, 7, 8, 9, 10 in a row. So all the way up to the 10th person. So let's think about this. No restrictions. Anyone can stand wherever they want. So it seems like out of 10 people, we have 10 choices for where the first person can stand. And that leaves 9 choices for where the second person can stand, which leaves 8 people left for the next slot, and so on and so forth until we get a straight up 10 factorial. That's our answer. 10, and these are all being multiplied together. That's why I put a dot in there. So this is the same question as, what if we had no restrictions? Well, if 10 people line up with no restrictions, there are 10 factorial possible ways for them to line up. And that's why 10 times 9 times 8, that's what 10 factorial means. Now, question number 10 on the worksheet said, hey, what if there's going to be 2 rows of people? That's supposed to represent 5 people in the top row, 5 people in the bottom row. And what if women are in the front row? Oh, it sounds like these are all the men and these are all the women. Actually, I'm going to change the wording and women are on top. So let's bring just being a little feminist just for the moment. Okay, or they'd be equal. But regardless, let's say we have the men in one row and the women in the other, and a totally different row. So how many ways can they stand if they're like this? Well, let's think about this. We have 5 choices for the first guy. That leaves 4 choices for the second guy, 3 choices, 2 choices, 1 choices. That's classic 5 factorial. And for the women, they can line up in classic factorial mode. Now that means that we take this line of men and we add it to this line of women. So in the end, that answer is 5 factorial plus 5 factorial. That's number 10. And then let's look at number 11 because it gets really confusing. 11 is, how many ways can the club pose if they stand in one row, but when men and women alternate positions? So it's back to the same old 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, one row, only this time this one has to be a man, and this one has to be a woman, and this one has to be a man, and this one has to be a woman. Man, woman, man, woman, man, woman. However, what if I started with women, as I should have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this time, women, and then man, woman, and the man, woman, and the man. This is hilarious. It's so fun to make these shapes, let me tell you. Okay, now, there's 5 men and 5 women in this group. So how many choices do I have for the first person, man? 5. How many choices do I have for this first woman? 5. Okay, I take one of them. One of them is standing in these positions, which leaves how many left for the next positions? Well, 4 men are left and 4 women are left. And that means 3 men are left after one of them sits here and one of them sits there, and 3 women are left, which means for the next part, I have 2 men to choose from and 2 women to choose from, and then 1 and 1. This is kind of crazy, but doable. Then, what if instead of having a man in front, I have a woman in front? Well, it's the same numbers. First, I place one of my women and one of my men, which means I have 1 less in the pool to choose from. So that leaves 4 left, which leaves 3 left after they get in row, which leaves 2 left for the people to fill those positions, which leaves 1 left. It's kind of silly, right? But ultimately, if I'm doing this correctly, which I hope I am, let's see, that should be, this actually works out to being 5 factorial. Do you see the 5? These are all multiplying, don't forget. So I could actually write that as 5 factorial times 5 factorial, because that's what's happening here. Here's the 5, 4, 3, 2, 1. times another 5, 4, 3, 2, 1. And then I can add it to this row, which is the exact same thing, 5 factorial times 5 factorial. Or another way of thinking about this is like terms. This is just heads up for algebra. That's really two of those expressions, 5 factorial times 5 factorial. So either one of these is totally appropriate. But if you want to think of it as an addition problem, I understand. I'm just giving you a little heads up that these are like terms. So if I have a 5 factorial times 5 factorial plus another 5 factorial times 5 factorials, that's like having two 5 factorial times 5 factorials. So this is a kind of interesting question. Let me know if you want to review it in person. I'd be happy to. All right. Thanks, kids.